the web assign. So do you do first and last or do the factors?
I did first and last, and I got like 14 as the biggest.
Okay, so 14 times a positive one would be 14. Factors of that sum to negative 15 would be negative 1 and negative 14. Those multiply together to give you positive 14, but add up to negative 15.
I have a question.
Yeah.
Do we like continue to break it down? Like if there's, for example, like an x instead of a 15, do we just keep breaking it down?
If there's an x instead of a 15, like there's no number here?
Yeah.
Then you would look for the factors of that number that add up to 1. So you would treat it as though it's 1.
All right.
Yep.
Yeah.
And then factor by grouping here, right? So I'm going to group it. From the first set of parentheses, you can take out an x, and I'd get 14x minus 1. Second set of parentheses, you can take out a negative 1, 14x minus 1. And then it's 14x minus 1, and then it would be x minus 1.
Yeah.
Any other questions from the website? We're good? Okay. So for P4D, like I said, it's the last one in this section, okay? It's called factoring completely. It literally is going to take and put together all of the types of factoring. So on your quiz on Friday, you're going to see stuff that are multiple types of factoring built into one, and you're going to see stuff that's just like straight up one kind of factoring. So it's going to be mixed together. More where there are multiple parts than there are just straight up one kind, okay? So that's why we're going to practice for today and tomorrow. So to go through all the different types of factoring, okay, we had our greatest common factor. If there were two terms, you either had the sum or difference of cubes, or you had the difference of two squares. If there were four terms, we factored by grouping, and if there were three terms, it was either a perfect square trinomial or traditional factoring like we did yesterday. So the very first thing you always want to do is check for the greatest common factor, because even on any of these types, the greatest common factor might be able to come out first. So first thing we're going to do is factor out greatest common factor. Then we're going to look at what's left. Are there two terms separated by, two perfect squares separated by a minus? Now that's the difference of two squares, okay? Are there two perfect cubes separated by a plus or minus? Now it's the sum or difference of cubes. If there are four terms after you factor out a greatest common factor, then we're going to factor by grouping. And if there are three terms you're looking to see are the first and last perfect squares, because then we're going to test for the perfect square trinomial, where we square root the first, square root the last, and double the product to see if it matches the middle. And if that's not the case, are there factors of the last that sum to the middle term, which is what we started with yesterday, or is there something on the front where we're going to multiply out that first and last or do the trial and error from yesterday? So all combined, you have the greatest common factor, the difference of two squares, the sum or difference of cubes, factoring by grouping, perfect square trinomial, and then your traditional factoring from yesterday. So there's 6 different types you're looking for, okay? There's 2, like after I check for greatest common factor, there's 2 different types. The first would be the difference of two squares. Where you'd get a perfect square and a minus between them. So then I would factor by square rooting the first one and square rooting the second one, and one gets a plus and one gets a minus. The other type is the sum or difference, because it could be either one, of perfect cubes. So this would be like an x to the third minus 127, both perfect cubes. So we would cube root and cube root, square the first cube root, so this cube root would be x, this cube root would be 3. Multiply them together, so it would be 3x, and then square the second one, and then we SOAP. Same, opposite, always positive. Then the 3, right, because factor by grouping is the only one that has 4. The 3 is either a perfect square trinomial, so it would be like 4x squared, 25, so that's 2, 5, minus 20x, like that. So I would look to see, are my first term and last terms perfect squares? In this case, they are. So then we test. We square root the first term, it'd be 2x. We square root the last term, it'd be 5. we multiply them together and then double that. And if it equals the middle term, ignoring the sign there, then I know it is a perfect square trinomial. And then to actually factor it, we square root the first one, we square root the last one, we take the sign from the middle, put it in parentheses, and square it. And then the traditional factoring like we did yesterday, if it was x squared minus 2x minus 24, I'm looking for the factors of negative 24 that sum to negative 2, which would be negative 6 and positive 4. Or something like 2x squared plus 7x plus 3, where we multiply the first and last. Find the factors of that sum to the middle term. Replace the middle term. And then factor by grouping. And I get 2x plus 1 and x plus 3. Or you could do your trial and error with that one. So those are 5, right? The first one was the greatest common factor, and then the one we skipped was the factor by grouping. But other than that, those are all the different types of factoring. Questions before we get into examples? Yeah, Hadley. Okay. So the only instruction on your quiz is going to be this: factor completely. That's it. Okay, 14 questions, all the same set of instructions. So you've got to be able to look at it and figure out the strategy to approach it. So if I'm looking at one, what is the first thing I'm always going to check for? Can I take something out of it? Is there a greatest common factor of 12x squared and 48? Yes. What is it? 12. Good. So I take out 12, which means I would divide this by 12 and this by 12. And I'd get x squared minus 4. Can I go any further with that? How? That's the difference of two squares. X and x, 2 and 2. One gets a plus and one gets a minus. You have to leave the 12. Yeah, the 12 goes nowhere. It stays out. Go to 2. Where would I start? Take out the greatest common factor, which this time is x. And then I'd get x squared minus 16. Am I done? Difference of two squares again. X, and then x plus 4 and x minus 4. Questions on that one? Go to 3. Greatest common factor? None. Now what? Are the first and last perfect squares? How? Yeah.
1 is 1 and 3 is minus 3.
So here's the tricky part of this. That's a -1 and a -9. Are those perfect squares? No. Okay. What I can do is what to change the sign on them?
Put a -1 on the outside.
Take out a -1. If I take out a -1, now I've got perfect squares at the front and at the end. If you don't catch it there, you would factor it like we did yesterday. We would do the first and last, and we would factor it, and you would actually find them repeat, but then you'd have a negative somewhere in there that you could take out. So it doesn't mean it's wrong. I'll show you both ways. But the first thing I would do is if they're both perfect squares but negatives, see if you can take that -1 out. Now I've got 9x squared and 1. This would be 3x times 1, which would be 3x. Double it, it's 6x. So it matches my middle term. So then the -1 stays on the front. I square root the 9x squared. I square root the 1. I keep the sign from the middle, put it in parentheses, and squared. That -1 has to stay on the front. So you don't have to do it because they're both perfect squares. If you didn't take out the negative, then you'd have to do that. So I would do -9 times -1, and I'd get 9. Factors of 9 that sum to 6 are 3 and 3. I'd replace my middle term with those. And then I'd factor by grouping. From the first set of parentheses, I would take out a negative 3x, and I'd get 3x minus 1. Second set of parentheses already has the 3x minus 1. So I'd take out that 3x minus 1, and I'd group together a negative 3x and a positive 1. So these are actually the same thing because I can take out a negative 1 on the right-hand side. And both of those would be fine as an answer. Questions on that one? All right, what can we do with 4? What's our greatest common factor? 3x. So I would divide this by 3x, and this by 3x, and this by 3x. And I'd end up with 3x, because the 3 goes into 9 3 times, and one of the x's cancel out. Plus 3 goes into 12 4 times. Both x's cancel out. Minus 3 goes into 3 1 time. One of the x's cancel out. And I'm left with 3x plus 4 minus x squared. Now, is that the order we're used to? No. So what are options that I could do? I can put the x to the front. It's going to be negative, so I would get negative x squared plus 3x plus 4. I can rearrange them.
Would it be wrong if we don't rearrange them?
You have to factor that further. So you can either do it that way, or you can make it 3x, and then it can be 4 plus 3x minus x squared, and you can do your first and last there. But you do have to factor this further. It's still a trinomial that can be factored. So even from the left side here, I still have 2 choices. If there's a number on the front, right, technically there's a negative 1 there, I can't just look for the factors of the last one that add to the middle term. So I can either change the sign by taking out a negative 1, making that a negative 3x, or I can do first times last. But you cannot just look for the factors of 4 that sum to 3x if there's a negative on the front of the x squared. Now I can. Now I can look for the factors of negative 4 that sum to negative 3, which would be what? Negative 4 and positive 1. Yep.
Would it be able to use another way and put 9 times 2?
The 9 times 3, like the first times last? Yeah, you could do it that way. You just have to factor out at the end. You'd end up with a 3x as a common factor at the end, and then you'd have to take it out. I think it's simpler to try to reduce your numbers from the beginning. If we've learned nothing from those like square roots, the faster you can simplify your numbers, the easier it's going to be. If you kept it like the one on the right, then I would be doing 3x. I would multiply first times last, so 4 times negative x squared would be negative 4x squared. Find the factors of that sum to positive 3, which would be a positive 4x and a negative x. Replace your middle term with those. And then factor by grouping. So the 3x stays on the front, and then I'd take out a 4. I'd get 1 plus x. Take out a negative x, 1 plus x. And then the 3x is still on the front. The 1 plus x comes out, and the 4 minus x gets grouped together. So both of these answers would have been accepted. Edward.
Yeah, but isn't that one 4 minus x and the other one's x minus 4?
Yeah, but we took out a negative 3 on the first one, so this negative would have changed the signs of those.
So the 3x is already on the outside, so we just take it. How do you get the 1 plus x in the spot?
So from here, from that step, I multiplied first times last, found the factors of that replaced the middle term, and then I replaced that middle term with those. So now this is what I'm factoring by grouping. I grouped those into I took out the 4 from the first two. I took out a negative x from the second two. And then the greatest common factor is 1 plus x.
Oh, I see, sorry.
That's okay.
Because I forgot that.
And then that gets grouped. I think the first way is less confusing. So I would probably try to do that. Try to make your x squareds come first and try to make them positive. It doesn't mean you can't do it the other way, but I think it's less confusing to do it that way. So if you have a negative, if they're out of order, put the x squared first. And if that x squared is negative, take out a negative 1 so that leading coefficient is positive x squared.
How did we do the first way again?
So I took out the 3x from the beginning, right? That was my greatest common factor from the beginning. And then I had this trinomial. It was not in order, so I rearranged it so that the x squared came first. So it was an x squared, an x, and then the constant. And then there's still a negative on it. So I took the negative out. Now I made it look like what we're used to looking like, and you just have to look for the factors of the last one that sum to the middle one.
Oh, so then you just did 4x and then...
I just did factors of negative 4 that sum to negative 3, which were negative 4 and positive 1. But that negative 3x has to stay in the front. All right, look at 5. What's happening there? It's the difference of two squares. It's super ugly, but it is the difference of two squares. This is a perfect square. Not that. This whole thing is a perfect square, and this is a perfect square. So what is the square root of x squared plus 8 squared? X squared plus 8. That would be the first term in each parentheses. What's the square root of 36x squared? 6x. 1 gets a plus and 1 gets a minus. Now there are 2 trinomials there, so I'm going to put them in the order that we should have them, decreasing degree. X squared plus 6x plus 8. X squared minus 6x plus 8. And I'm going to see if either of these can be factored. Are there factors of positive 8 that sum to positive 6? What are they? 4 and 2. X plus 2, x plus 4, or x plus 4, x plus 2. That doesn't matter. Are there factors of positive 8 that sum to negative 6? Wait. Negative 4 and negative 2. And that is as factored as you can get it. So every single one you've got to check to see if you can keep going. All right, so 6. What do we, first of all, check for greatest common factor. Is there anything that can come out of all 4? No. So then I do what? Factor by grouping. What can I take out of both 3x to the third and x squared? X squared comes out. And I get 3x plus 1. What can I take out of negative 27x and negative 9? Negative 9. And I'd get 3x plus 1. Now the 3x plus 1 repeats, so that comes out to the front. And I group together x squared minus 9. Can I keep going? Yep, how? Difference of two squares. 3x plus 1 gets factored into x plus 3 and x minus 3. Okay. Go to 7. What can I do here? Is there a greatest common factor?
Yes.
What is it? 2x minus 1. So that comes out of here, and one of these is gone. So that's gone, and I end up with 4x plus 2x minus 1. And I get 2x minus 1 times 6x minus 1. Questions on those? All right, I'm just going to throw up two more that have that we've gotten questions on, like from the previous sections. I would like the harder ones from the previous sections. Okay, so if you have 125 x to the 6 minus 125 x to the 6th minus 8y to the 9th. What are those? Look at the numeric part of it. What's true about 125 and 8? They're both perfect cubes. And then how did we test for perfect cubes on the variables? What's the rule?
If they are a multiple of 3.
Good. If they're a multiple of 3, so these are perfect cubes. When I cube root the 125, I get 5. When I cube root the variable, what do I do with that exponent? Divide it by what? By 3. Good. So this would be x to the 2nd. That's the cube root. And then this would be 2y to the 3rd. So then my pattern would be 5x to the 2nd, 2y to the 3rd. I would have to square that, so I'd get 25x to the 4th. I'd multiply these two out, 10x squared y to the 3rd. And then I'd have to square the 2y to the 3rd, and I'd get 4y to the 6th. And my signs are same, opposite, always positive. And then the other thing that tends to stump people are if there's like a variable at the front and on the back. So for these, I would ignore the variable at the beginning and just look at my terms and see, are there factors of -8 that sum to -2? They would be what? -4, +2. And then when I set up my parentheses, the first spot gets the x, the last spot gets the y. And then I fill in the coefficient based on the factors I just found. So if there's a variable on the front and on the end, they should both be involved in that middle term, okay? If it was just 2x in the middle, that would be prime. Questions on anything we covered in factoring? Because again, your quiz is all of it. Yeah.